All right, so what is going on, everybody? It has been probably 2 or 3 months since I made a last video, but I'm back. And today I actually wanted to talk about error handling in Next.js specifically, but we're also just going to talk about it in like a general sense. And the reason why I'm making this video now is actually because my most recent backlog item for work was improving the error handling of my Next.js app. So I've actually been working the last month basically on just making the app as robust as possible, adding logging, making sure when an error happens, the user knows what happened, and for the developers that they also know what happened. So it's been on my mind a lot recently. I also talked to a friend who's just building a Next.js app, and I was looking at his code base and there was no error handling whatsoever. So I kind of made fun of him, telling him just add a try catch at the very least, so you can, catch errors and the application won't crash. But he was laughing at me, telling me that it's not needed for the MVP. So we had a kind of debate about it. So I thought I would just make a video about it and get the ball rolling again with my YouTube channel. So we're actually going to look at, one of the most famous books about software development called KilanG, and it specifically has a chapter on the clean architecture, which is in a broad sense, framework agnostic, programming language agnostic way of building apps. So we're going to take a look at this, which is kind of in the broader sense. Then we're going to look at somebody who actually implemented this clean architecture in Next.js. And for my use case, this is a bit too much over engineering. I mean, it's really good, but I don't need all of the stuff that's mentioned in here. I just needed to take inspiration from some of the stuff, but nonetheless, it's still nice to see an actual Next.js implementation of this kind of broad, concept. So after we've done that, we're also going to take a look at actually taxonomy of errors. So if you don't know what this word means, it just means categorizing. So we're going to try to put different errors in boxes, so we know what kind of different errors exist, and hopefully I can convince you that there are two kinds of errors. There are unexpected ones and there are expected ones, which you should handle. Then once we kind of we've looked at the Next.js stuff, we've actually categorized errors, I hope to just finish it off with a couple of examples from my own code base of what I've been doing to show you how I handle errors in Next.js. All right, so let's actually get back to this diagram. And what this layered architecture is showing is basically your outer layer, which is frameworks and drivers. So here actually we have things like Next.js, any database frameworks you use, React. I thought that was already interesting because most of the time we think as the framework as the central part of our application. It's everything we're going to do is based on how that framework works. But in the actual architecture, it's the most outer layer. It's the least important. It should be able to be switched out. So if you want to switch to Angular, you will have to re-implement the front end, but all the core logic, the inner stuff, that's going to stay the same. And this makes your software or your app much more modular. You can just swap pieces out if they're less important. So the outer layer is your frameworks and drivers. The inner layer we're not going to talk about too much, but this layer is basically just a communication between your outer layer and your use cases. So it changes the shape of the data so that applications can speak to each other. But like I said, we're not going to talk about it too much because I don't use it. Then we have the actual use cases or application business rules. So your use cases could be creating a to-do item or basically some kind of database interaction, stuff like that. So they're isolated pieces of code that do specific things that are related to your business. And at the very core of it all, we have the entities or your enterprise business rules. And in Next.js or JavaScript, these would simply be objects that contain the shape of your entities. So for example, you could have a file with a file name, a URI source, and other kind of properties on them. And the main takeaway of this layered architecture is that dependencies can only point inwards. So the entity is the most inner. If it changes, everything above it will probably have to change. And that's why these should be the least likely to change. So if you can imagine in that last example I gave where you have a file with a couple properties, if all of a sudden you want to add some pagination to that file and you want to add, for example, the page size and the page index so that you can look at specific pages within that file, then all of a sudden your use case might have to change because it now has to get the file based on a pagination. So it has to calculate page size times page index so that it can find which page to get. So the use case is going to have to change. But now the web, the Next.js part, the framework is going to have to change as well because it now needs to get that from the user. So maybe somehow it needs to find what page the user wants to select from a form. Maybe it then needs to send that to an API request or a server action in Next.js so that it can eventually call the use case. So now you see that the entity, if it changes, all the layers above change. But vice versa is not true. If a use case wants to calculate that pagination stuff differently, by let's say, I don't know, for some reason you want to multiply everything by 2. So if the user types page 4, then they get page 8. I don't know why you would want to do that, but that's a change in your business rule. But it's not going to affect the underlying entity. It still behaves the same way. And now the main takeaway of this all regarding error handling is that your use cases should be just throwing errors, and your frameworks should be catching those errors and dealing with them in a specific way. Because if you think about it, you're going to have different pieces of software calling this use cases. And if you start handling those errors in the use case, then you cannot customize the behavior for different applications. And that is not good. It takes away flexibility. So what we really want is the use case to be like this. It doesn't see anything on the outside. It takes input, it tries to validate it. If it doesn't work, throw an error. Let the person who called that use case deal with the error in whichever way it wants. So I think that's a useful way of thinking about error handling. You should define this boundary and try to make the thing throwing the errors like unaware of who's calling it. So that's the first step into understanding error handling. All right, so enough theory. Let's actually get into somebody who actually built clean architecture in a Next.js project. And I kind of want to start with, let's just start with the server action. So this person is like making a small to-do app just to show how clean architecture works in Next.js. And you can see in his server action, so he has, todos.tsx. And in here, he's going to call, this is toggle to do, but somewhere in this file, he basically calls a server action, which calls, like, let's say create to do. And what create to do does is it gets the data from the form, gets the session ID, it gets this controller. So that was this layer. I'm not using it, so I'm also not going to focus on it. But he basically calls the create to do controller, which is going to do all the stuff related to adding a to do to a database, which we'll get into later. But you can see because we're on the actions, so actions is framework related. It's a Next.js feature, so it's on the most outer layer. We can see what it does here. It actually catches the error and it deals with each error specifically. So if it's an input parse error, it returns an error with an error message. If it's an unauthenticated error, it returns this specific message. So you can see that the outer layer is specifically consuming different errors and handling them in its own way. So if we quickly look at the actual use case, then what we can see in the use case is that if the input is below a certain length, then just throw an input parse error. So the create to do use case, again, it's like this inner thing. It doesn't know who's calling it. It just sees an error, it throws it. It doesn't try to handle it in any way. And then in the actual controller, like I said, I don't use it, but there's some other stuff going on where basically if the session ID doesn't exist, then throw an authenticated error. So these different layers that throw different errors, and the responsibility of the outer layer is to always just deal with the errors specifically so that we keep flexibility. So now you can kind of see the basic idea of someone who coded this out, and I recommend you just check out this project. Just search up Next.js clean architecture and learn about it because it's useful. So, okay, now we've looked at the theory, we looked at someone who actually implemented it in Next.js, and now I'm kind of summarize all of that into, like, if you want to start using this tomorrow, how can you do it? Because this is obviously like, if there's a spectrum, this is all the way at the end, and maybe for some people, like, too much to start. So let's try to go somewhere in the middle of that spectrum. If we look at this first example, this is your classic server component in Next.js, and it's async, so we can just get some information on the server. So get user is a database call, and nothing can go wrong besides an unexpected error. Like normally here you might pass in like a UUID or something, and then this get user function is just going to try its best to get from the database. It either returns nothing or something unexpected happens, like a network error. So maybe, if you think back to fundamentals, you're making a HTTP request to a server, and that HTTP request is traveling on a TCP transport protocol, for example. And one of those protocols, the TCP handshake fails, and you get a network error. So that's going to stop somewhere in the middle of this call, and it's going to break the code basically because an unexpected error happened. So in Next.js we have what is called an error.tsx file for this. So you can call or you can create an error.tsx file, and whenever such an error happens, like that will be your last resort. It'll be your fallback. So look into error.tsx file. It's basically just it's your final catch-all, and it will catch these kind of errors and basically just tell the user like, look, retry. If you retry, there's a 99% chance it's going to work because something unexpected happens that doesn't normally happen. So these are kind of the easiest ones to deal with, and I deal with them with that file. Then let's say you're in an actual API route. So it's a post request, and what we have is we have get user. So again, this can fail for the same reason. You can get a network error. And here we're actually trying to get a page and a page size from the query parameters. So this is now a different kind of error, because let's say we call the next thing, which is, get projects. We've authenticated the user and we want to get projects at the page with a specific page size. But this could fail because, maybe the user didn't give a page or a page size. So this will fail because this is invalidated. And that's a different kind of error. That's a validation error. We should always check in this API endpoint if the page and the page size are given. If they're given, are they numbers? If they're numbers, are they within a specific range? Like if you give a -4, that shouldn't be allowed. And for each of those cases, we give like a generic message back to the user. So we don't throw an error. We just check, right? We just check like if page is less than 0, then then return. And here you can just say error. And then let's just, whatever you want to put in your message. So then the user is going to get back a specific JSON object. And now we've kind of got into unexpected error, which can be further defined as like maybe a network error. And then we have expected error, which one of them we found is like a validation error. So now we've gone over 2 errors that specifically happen on the server, which in general you have a bit more control over than, let's say, when you're on the client. So this is an example of, we're in like a random word function and it has a use effect. I don't recommend using a use effect to actually do client-side fetching, but it is kind of the most simple way you can do it, right? When a component mounts for the first time, this will just be called. And what you do in the use effect is you fetch some random API point. So in this case, I'm doing like a fictitious client component that is basically just going to get a word from some fake API endpoint that gets a random word. What can go wrong here is, again, we can have this unexpected error. Any HTTP request, I hope you get this by now, can be an unexpected error. But maybe this doesn't actually, when you make this call, maybe it doesn't throw an error. It actually does return a response, but the response is not okay. And if you're not familiar with this, what this basically means is that whatever API request you made, the server responded that something is wrong with your request. So, for example, in this second example I showed, maybe if someone calls this API endpoint and they don't provide the page and the page size correctly, we don't throw an error, we just return something. And then the person who called that will see that, the response is not okay because I didn't provide a page or page size. So now you kind of get into like 2 separate errors. So how are you going to deal with those? You have the unexpected ones, and I'm talking as a client, right? As a client component, you now have to, does it get ugly? You have to maybe wrap this in a try catch so that you can catch the unexpected errors. And then the expected ones, you have to check if response.okay is good. And then only after you've done all of that, you can actually use the data that you got back from the endpoint. And that might seem like a lot of work for something that happens, or for something that almost never fails, actually. You're just handling cases where 1% of the time something does go wrong. So that's another situation we have to think about. The last example I want to show is through a server action, because I think many people use these. You have like a client component that's a login form. It tracks an email and a password. You use React's use action state, which is just a hook that accepts an actual server action. So in this case, that's the server action, which I'll get to. And it returns an action that you can enter in a form, so that when you submit the form, you're basically triggering this function. I've made many videos on what these are and how they work, so check those out. But the idea is that you do something on the client and you call a function on the server. So now that we're on the server, the user submitted the login form, we try to get a username and a password. We got to make sure we validate this because that's something that can go wrong. It's an expected error. We try to log in, which is a database operation, so this can always go unexpected. And then if it works, we create session. Create session is also going to be a database operation because you're probably going to add this session to your database. So again, now you have two things that can go wrong unexpectedly. You have validation. So it would be nice to just see like an example of how I handle this. So that's what I'm going to get to now. Okay, so finally, the moment you guys have all been waiting for, some actual code. This is the application that I've been working on. So there are a lot of times in my application where you need to fetch data on the client because, for example, in this feature, it's like a file viewer, and in the beginning, you just show all the root directories, and the moment the user clicks on something, you're going to start fetching data from the database. So, for example, when you click on this arrow button, it's going to actually start fetching the child folders of this parent folder. So for that, I'm actually using the SWR library that's by Vercel themselves. So Vercel, the owner of Next.js, they made a client-side fetching library that handles caching and other nice things. So I use that. And the reason why I use a mutation here is because it gives back a trigger function. And this trigger function, as you guessed, can trigger a fetch. So when I click on this button, I'm calling the trigger. That's basically how it works. What gets triggered, what actual code gets triggered? Well, you pass in a URL to an API endpoint. So that endpoint is this one here, you can see. This is going to be, how I deal with errors. So the first thing I do is I wrap everything in the API request with a try catch. The reason is that a lot of these things can fail unexpectedly. Get current session goes to the database. Get current project goes to the database. Get child folders goes to the database. So a lot of these things could unexpectedly fail, and if they do, they will be caught in this catch statement. Now, in this catch statement, I check if it's a database error. So in my actual, where I fetch stuff in the database, if there's something that goes wrong, I throw this error specifically so that I know I can differentiate a little bit about what went wrong. So you have this database error, and otherwise it's probably some very unexpected, unlikely network, Wi-Fi error. So I just said fail to fetch and, try again, basically. So that covers all of these unexpected ones. And the expected ones, what I do is and maybe also it's worth noting that when I catch these unexpected errors, I actually return them so that the client can receive everything in an expected way. So it can always see what was the success message? Oh, okay, so it was false. If it's false, then there should be an error message. So I don't throw another error here, because otherwise in here I would have to catch it. And I thought that was a bit annoying. So I just, in here I deal with all possible errors and I return the same format of JSON every time. A success, if the success is false, an error message, and always a status code. So you're going to see that. Then the expected errors. So, for example, if the user is not, if there's no user for this API endpoint, obviously we don't want to let the user trigger it because they're not authenticated. So deal with that explicitly. Success false, error unauthorized, and a status code. Then get the current project. If there's no project selected, then this operation is meaningless. You need a project. So again, success false, no project found. Then I try to get an asset ID, because in this case, I'm trying to find all the children of this asset ID. And for that, I just, if there's none included, I just send back a message, same idea, success is false, and here's the error, here's what you need to do. And then finally, if everything is a success, so I get the child folders, and I map those to the specific way the client expects them, then I can send success true, and I can add data, which is the actual data. And so that's the pattern I'm using for basically all of my API endpoints and server actions. I'm always dealing with every possible error that can happen, expected or unexpected, and I'm deliberately returning JSON that the client can consume. So that way the application can never crash because you have full coverage of errors, and the client is forced to actually deal with those errors by checking if the success or if the request was a success. And if it was, you can go ahead and send your data. Otherwise, show an error message. So maybe I can quickly show what that would look like. If I, let's say, deliberately change this to something that would fail, and now I refresh the page. I try to get here, then you can see basically error message on the bottom, unknown database, because something went wrong. I basically changed this to be a database that doesn't exist. Hopefully this makes sense and you can kind of copy the same style. I showed here a API route endpoint, but it's the same thing for server actions. And I think as a closing note, I would like to fire a question back to you guys on how, because right now in every endpoint I have this duplicated code. So I'm wondering, would you guys turn this into a function and just always write that function in here? Or how can we clean this up a little bit? Because right now I'm copying the same lines of code for basically every API endpoint. I know a function is an easy solution, but just wasn't sure. Anyways, hopefully I'll be making some more consistent videos.